Hi everybody, my name is Marius, as always. Once again I'll be doing a set of videos starting today, and of course today what I'll be talking about is the ABCs of IPSec on HP equipment video 1. Okay, so effectively we're starting another series of videos. I've been seeing a lot of questions around IPSec recently. I've been doing a lot of IPSec on HP equipment quite recently as well, and a couple of scenarios where the customers weren't quite sure exactly how it worked. What you need to understand, of course, in this series of videos, there'll be a couple of them, right? Don't want to reinvent the wheel. Just want to show you how it translates back into the actual HP equipment. But the most important thing is that you understand how it's constructed inside the configuration. So instead of building it up into a configuration, I thought, so let's get it out there. Let's start off with a configured set of devices. So I'll configure them with you today. We'll go through a couple of things. I wrote some things down here. And the most important thing that we need to get through is the actual configuration of the actual device itself. Right? Once we've configured them, that'll be the end of video 1. Okay, once we have a working IPSec environment. I then want to take some time afterwards, and for the people, I think that'll be easier for you to start breaking down the phase 1, phase 2 approach, right, with some debugs while it's running. I think I'll go one step further and I'll explain basically what the Diffie-Hellman group does, how that actually works, transfer of keys, what IPSec P, or some like people say IPSec P, how does it fit into this whole story, right? And because at some point you have to specify IPSec P or manual. So for today, it's actually going to be quite simple videos. Set up IPSec, get it working. Once we have it working, I'm going to set it up in the base of rules. I'll write them down here. I've made some notes here that I want to do, because what I want to do is just touch almost everything. That's not necessary. It's actually much simpler than I'm going to do today. But I actually want to mess around with a couple of things so that we can get some configurations into the config set, and that I can discuss in the future then. Okay, so once we've set this up, a good idea for you would be basically to try and get this working on some VSRs. Once you have it working, simple enough, what I can then do is just go through the configuration explanations right itself. Okay, so without further ado, let's start that. Okay, let's just get a pen selected here. Let's see, let's start with a white pen today. That's should be interesting. So effectively what we're going to do is going to be really simple. Okay, I'm not going to complicate these things a lot. And what I've done already to save us some time, I've got router A and I've got router B here. Right, I've got a 172.16.1.0 network here, .1 and a .2. This is something that you'll have to make some notes on, afterwards if you want to reference back to this. This is a 10.1.1.0 network /24. Everything as a matter of fact /24. This is .1, and this is a 10.1.2 network. All right. Effectively, what this is just a loopback interface. Easy enough to work with, and a loopback interface. Okay, so what I want to talk about is there's some defaults that's already set in the router itself, so I can get this up in a couple of steps and get it working. I don't necessarily would be doing you many favors here, because the idea rather is to investigate a little bit more configuration, get the configs out there, and once we have those configs working, I'll try and remind you of the defaults of the actual device themselves. And you can make a decision whether you want to change that. So what we'll do is we'll look at IPSec P. We'll definitely use that because IPSec P, that would help if I do one P there. And the reason I want to do IPSec P at the moment is so I can talk about the IPSec Key Exchange. Yeah, the IPSec Key Exchange itself, and this is basically IPSec phase 1. We'll set some settings there. Now haggle. I don't know if you know the keywords haggle. So I want to reference this. So I'll be jumping to and fro between this. Right, so from a hashing algorithm, the default is SHA-1. Okay, I want to show you the defaults there, and of course from an authentication point of view, this is typically the type of authentication we use. I'm going to use pre-shared keys for today. That's the default, right? But you can also use certificates in there, but I will be looking into that. Of course, group, I think let's just change something. Diffie-Hellman group 2, so we have something to show. Right, the lifetime is typically 86,400, which is 1 day, seconds. So let's make that 3,600 seconds, just because we can. Yeah, I'll talk about the benefits and stuff later on, in other videos. And of course, encryption algorithm by default is DES, so let's make it AES. Okay, AES 256. That's IPSec phase 1. Okay. Now once again with IPSec phase 1, that's what we need to get up and running. You'll see my procedural setup is I always start with ACLs. First of all, if you saw my first video, make sure your connectivity is working. Right, connectivity is working well. Okay, we'll first do some testing here to make sure everything is running perfectly. Then we'll set up an access control list to go from 10.1.1.0 to 10.1.2 and vice versa. Right, so we'll set up 2 access lists, and let's say that will be access list 3000. The next thing you want to do, of course, is you want to set up your IPSec proposals, right? So I'm going to work on my IPSec proposal, and inside the proposal I'll make the changes as we set here. You know, SHA-1, we're going to be using the hashing algorithm appreciate key. Even though that's default, I just want to show you how to set it up. I'll show you the SHA as well. Diffie-Hellman, I'll change that to type 2. And of course the 3600 seconds there, 3600 seconds, that's we're going to change itself. And AES 256 not default, the default there is DES. Okay, so I'll show you once we've set that up. And once you've set up, of course, your IPSec proposal, the very next thing to do is to set up a transform set. Okay, and the transform set, let's talk about that a little bit. That's IPSec version 2. IPSec version 2, that's the start of IPSec version 2, of course. Negotiation is we're going to be using ESP for today, ESP encryption, and we're going to have ESP authentication. Yeah, so ESP encryption at the moment, I would say the default is DES. So let's say we're going to use AES. Let's make it nice and secure, 256. And authentication by default is SHA already. I don't want to move away from SHA-1. That's a great example to have there. Okay, so once we've got the transform set going, I need to bind it to something, of course, which will be the IPSec policy. So what we'll do is we're going to actually take the access control list and we're going to bind it into this policy, right? We're going to take the transform set and we're going to bind it into this policy. And after that, we're going to set up a remote device address that's allowed to use this policy. Okay, so we'll talk a little bit about that as well. So those are the 3 major steps that I need to get this done. I think maybe just from time-wise point of view, let's say the ASA duration by default is 3600, but let's say we're going to make that 600 for now. Let's just change it. Some stuff we can change. Yeah, and we'll set the duration up in there. That's the policy itself. Then, of course, we have to create very important, because we're going to be using IPSec phase 1. We're going to be using appreciate keys. I need to somewhere go and set up a appreciate key. Okay, of who's allowed to actually set up an IPSec version 1 tunnel with me. So, which would be the other side. So I'm going to then say, well, that's the next step there. I need to set up an actual key chain. Right. So once we set up a key chain inside the key, we're going to use appreciate key. And let's say with a password of ABC network. Okay, I'll show you when we get there. Anyway, that's ABC networking. Okay, whatever the case may be, we decide to choose there. Okay, so once we've got all of that set up, all we've got to do then is bind it to the interface. Okay, simple enough. How's that? Okay, so I'm going to keep this page open. Let's jump into the next page. Yep, so I can do some configurations for you and just show you some stuff if I need to. So let's start it up. I'm going to just quickly repeat the little design here. I've got router, and they connected together. Alright, and so just we can keep on jumping between them. This I said was 10.1.1.1. This network here is 10.1.1.2. I'm lying to you. 10.1.2.1, yeah. Okay, so I wonder why that is doing that. Anyway, so 10.1.2.1. Okay, and what we've got here is 172.16.1.0.1.2, and this is router A and router B. Right now this should all be running. Okay, so let's see if I can get them going. Okay, there's one. Like I said, I'm using VSRs here, so that's router A, router B. So let's get right into it. Okay, so if you can see there, I'm going to just do a quick display interface brief. Okay, and what we should see the 172.16.1.1 is connected and the loopback 100 is 10.1.1.1. Okay, so can I ping the other side? 172.16.1.2. Yep, I can ping the other side. Can I ping 10.1.2.1? Yep, I can ping that. And can I ping minus A from 10.1.1 to 10.1.2.1. Not 13. Yep, I can do that as well. Okay, so in theory, all my testing should be done. Okay, you can ping, of course, vice versa, but because ping is a two-way thing. I've now pinged all the possible variations that we have for this environment. Okay, so what's the first thing we said we were going to do? I'll be working between the two. So just to show you how to set it up, and you can see double. Okay, so I'll say IPSec proposal. Okay, and IPSec proposal, you have to give it a number. This number is quite important because the higher the number, it goes down a list of numbers to choose a proposal that matches up on the other side. Like I said, I'll go into the details of the discussion a bit later, but let's go, this is IPSec proposal 1. Okay, and if you hit a question mark right now, you've got a couple of things happen. Remember what we said before. Okay, so you've got an authentication algorithm. What did we say we were going to make it? Authentication algorithm was going to be SHA, if I remember correctly. SHA. Okay, that's done. Then the next one is authentication method. Now the authentication method by default should already be pre-shared keys. Alright, but the options you have is pre-shared, DSA and RSA. Okay, so for now I'm going to say pre-shared key. Okay, if I display an IPSec proposal, okay, you'll see that there's a second one created. You've got a default and you've got a new one that I've just created, which is 1. Okay, so at the moment everything is still the same. Nothing's changed. Okay, we did say we wanted to change the encryption algorithm, yeah? So the encryption algorithm, we said we were going to make AES CBC 256, if I remember correctly. Okay, and of course Diffie-Hellman group was going to change. So the Diffie-Hellman group, as I said before, you've got multiple groups, 1, 2, 5, 14, 24, depending on the size of the bit and how you want to set it up. So for now, we may say we're going to make a Diffie-Hellman group 2, if I remember correctly. Okay, if I now do a display IPSec proposal, you'll see I've got some differences in there. I'm still going to change the time just now, but they're starting to change now. Okay, so depending on the other side, if I don't create a proposal on the other side, what would happen is it's got a default of the default. What would happen with IPSec negotiation is that it would actually find the matching proposal with the highest number, of course, and in this case 1 wouldn't work. It's literally the odd one out because I've made some changes to it. Defaults would match, and that's how it would basically set up initially. Okay, so but for now we still wanted to change the time. So there's SA duration, right, and we can specify the duration from 60 seconds to 600 to 4,000 seconds. So we said we're going to make it, if I remember correctly, 3,600 seconds, yeah, which is 1 hour. Good. And let's see, and that's all changed now. So if I do this display current configuration pipe beginning with IPSec. Okay, there it should be IPSec proposal 1, and what I'm going to do is, this is just the easy way to copy it. Okay, is copy that there. Okay, I shouldn't have done that, but anyway, it's happened. And let's see, and I've got the same thing over here now. A bit of a lazy guy. Display IPSec proposal. Okay, do we have a matching proposal? We have a matching proposal. Okay, so that's pretty cool. So the proposal is done. If you go back to the previous slide here, and we view this guy, let's see, we click on that. So we've pretty much gone the proposal route. That's set up. Okay, I'm going to set up the access list just now. Okay, since we have that going there, I've checked the connectivity. So the next thing we want to do is access list, and then we want to start working with IPSec phase 2. Okay, let's get that going. Okay, so access list. Access control list advanced 3000. Let's make it rule 10 permit IP coming from a source of 10.1.1.0 going to a destination of 10.1.2.1.0. Okay, display this. That's it over there, and let's do the same thing over here. Okay, that'll open our access control list advanced. I'm already in the sys there, and we said 3000. Let's keep it the same. Rule 10 permit IP coming from a source of 10.1.2.1 going to 10. Okay, should have put destination in there, that would have helped a lot. Thinking about the next step already, you see. Display this. Okay, so it's very important to get the mirror of the access list on both sides. Okay, as I go through the future videos, you'll see how important this becomes in future. Okay, so pretty much a mirror of what I have before. Okay, so I've now got an access list 3000, and we've got an access 3000 there. So the next thing that I need to do is an IPSec transform set here. So the transform set is going to ask me for a name, so let's call it transform set 1. Right, and that's it. We said we're going to do ESP. Let me just show you the options then. Okay, we've got AH with an ESP. Right. Once again, future video, I'll talk about the differences between them. When do you use which one? Okay, AS versus ESP versus a combination of either AH and ESP, whatever the case may be. All right, and there's some encapsulation modes and so forth. So we said we're going to change a couple of things here. Okay, so but for now, I want the ESP encryption. If I remember correctly, the encryption algorithm we said was going to be AES, yeah? AES 256. There it is. And we're going to go ESP authentication algorithm is going to be SHA-1. Okay, so that's important to me. So let me just check my screen here. So we've now set up the transform set, which we said was going to be ESP and a SHA-1. Okay, so I'm very happy with that. We've done the two things there. Okay, so we also wanted to set up, let's quickly see if we do a question mark, if there was anything funny I could still set up for you. PFS, okay, that's for IP version 2. We're not going to run that today. Right, security log file, that's pretty much it that I'm going to set for now. I don't think there's anything funny we can set here still. Okay, we can set the encapsulation mode if we wanted to, but for now I think we're quite good. Okay, so display current configuration, pipe beginning with transform set. Okay, so I'm very happy that we can copy this over as well. Control copy and boom, done. So now I've got a transform set running. So at this point, what I need to do, I've now got my access list and I've got my transform set running. So I can start with an IPSec policy. Okay, IPSec. This is things where things get a little bit more interesting. Policy. And if I hit a question mark, I've got a policy template as well. Future video, I'll discuss the differences between them. Yep, good. For now, I'm just going to use a standard policy. There's a very good reason for it. But as I said, in future we'll discuss. I've got a given name, so let's call it map1. And very important, now I've got a choice here of 1, 2, 3, 4. How you do this has got a huge impact on the access list in future. Okay. Anyway, we'll discuss that as we go forward. I found out some very interesting things here before with this. I actually wrote a white paper as well as on the internet somewhere, right, where we actually discussed the actual maps. If you use the same name with different sequence numbers, what happens to access lists that's bound to different sequence numbers. But that's, of course, I'll put a video together for that as well. That's the plan at least. Okay, so for now, the big question mark now is, do we use IPSec P or manual? Well, for now, we said we're going to use IPSec P because we want to go and use key exchange. All right, IPSec P, enter. So what's the first thing you need to do? You need to basically say security access control list 3000. I'm going to hit the question mark, the aggregation. Like I said, we'll be discussing that as well. For now, just security access list 3000. Okay, standard, nothing funny about this. Once we have that, we want to set up the transform set, and we call it tran1, if I remember correctly. Yep. Okay, and then I've got display this. Up to this point, I've got the following, and I want to say is a duration. All right, what do we say? 600, I think it was 600 seconds. Yeah. Sorry about that. Alright, it's going to be time-based, of course, or traffic-based. It's time-based. How can I forget? Okay, 600 seconds. Brilliant. Okay, so we've got something like that going at the moment. I can also, of course, have traffic-based as well. Or you can have a combination of the two, whichever. Good, so display this. Up to this point, everything is going to be the same on both sides. So what I'm going to do is just copy this, once again, being a very lazy guy here. Or maybe clever. Okay. Good, display this, everything is the same both sides, happy about that. Okay, and then I have one more thing to do, is the remote. I've got two ways of doing this. I can either use a string host name of the other device, or I can actually use specify the remote address itself. So for now, I'm going to say the remote site that I want to set up is going to be 172.16.1.0, and if you hit a question mark there, I need to put a mask down. Yep. So 245, 245, 245. Oh, sorry, I just have to put it down like that. That's fine. Okay, and remote address, I'm going to try and do it this way as well. Remote address is 172.16.1.0. Brilliant. Okay, and we say, let's just quit this guy out of here, and quit, and now let's quickly go and see. There's one more thing we have to do. We mustn't forget that. It's the keychain. Display, current configuration. I just want to make sure everything is right, beginning with, okay, transform set. Okay, happiness is. It's always nice to double check, make sure. My transform set is correct, my policy map looks pretty cool, my IPSec proposal is running like a charm. All I still need is, of course, the keychain. IPSec keychain, and let's call it key 1. Okay, so I've got that. I'm going to say the options here is appreciate key, or some other ways of doing it, but for now we're going to use that's RSA and so forth. But for now we're going to say appreciate key. Appreciate key, and appreciate key can either be based on the address or host name. So I'm going to make it address, and this time basically you'll see that we're going to say for the address 172.16.2.1.0. Okay, and this time if you hit, this time it's got the mask. Okay, that's where I got confused. Sorry about that. Okay, 245, 245, 245, 0. So you can actually open it up to more. So if you make it specific, you need to create a key for every single device. Okay, if you open it up like this, all devices within 172.16.1.0, you can also make it zeros. As a matter of fact, let's do that, just to show you. Okay, so you can make it zeros, and then of course we're going to specify the key. And key has got two options, cipher or simple. For now we're going to use simple, and let's say ABC networking. Boom. Okay, ABC networking. Very happy with that. So if I do a display current again, quit display current. I love doing this. But beginning with IPSec key. Okay, sorry, that should be bound together. Let's do just transform. It's easier. I know if I actually put them in inverted commas it will work, but this is what I want. Okay. And up to there. Control copy. Boom. Simple. A, B, C. It would, by the way, work if I did cipher and just copied everything in, but I like to do it this way. ABC networking. Okay, and there it is. Good. And let's just do this. Display current configuration pipe beginning with. Okay, transform set. Transform set. Let's see. I've got IPSec P. I've got my transform set running. 3000. I've got my appreciate key address. Everything seems to be pretty good and up and running at the moment. So that's configuration done. So display interface brief. Display interface brief. Let's just find the interface that we have to go to. This is Giga 220. Yeah. Interface Giga 2/2/0, and I say IPSec applied policy and map 1. And I say display interface brief. Thinking way too fast here. Giga 210. Interface Giga 2/1/0. IPSec apply policy map 1. Okay. And in theory and principle and everything else, this should be running quite well. Good. And just to verify, display IPSA. There's been no interesting traffic yet. And display IPSec SA, and there's nothing there yet. Okay, just to verify. So if I ping 10.1.2.1, it works still well. Why? Well, I'm not hitting interesting traffic yet. Okay, first I have to generate interesting traffic. So let's ping -a coming from 10.1.1, 10.1.2.1, and this time you'll see it's slightly different behavior. Yep. Okay, so very interesting here. I know exactly what's wrong, by the way. Okay, 100% correct. Okay, so we're going to fix it just now. But what you want to do now is, and this is good, is I want to show you a bit of a debug going here, because this is where people get confused, or what's wrong. Because if you get to this point, I mean, everything looks right. Okay, but effectively what is wrong at the moment is basically the IP address inside the policy. It's not a correct IP address there. You have to specify the IP address there. Okay. So effectively, let's go and do that quickly. So let's go to IPSec Policy, and we called it map 1 and 1, and display this. So we're going to say the remote address is 172.16.1.2, and we do a display this. Okay, and we do the same thing over here. IPSec Policy, and we say map 1, okay, and display this. Same thing. Remote address 172.16.1.1, and display this. Good. Good and good. By the way, I just want to see something. Display IPSA, still good, good. And then we say ping minus A coming from 10.1.1, ping 10.1.2. Good. Okay, cool. How cool is that? Now suddenly it works. Yeah. Okay, I'll explain this to you and how to debug something like that. So in the future videos, we'll actually go into it. So if you do a display IPSA here, we'll see that I've set something up to 1.2, and if you do a display IPSec SA brief, right, you'll see that there's two SAs set up, or as you might call them, SPIs set up to the other side as well, and vice versa. Okay, and what we'll do now is, or not now, in future videos, is I'm going to actually start tearing this a little bit apart and looking at the actual walkthrough. And the walkthrough I want to do is the following. Okay, terminal debug. Okay, terminal monitor, that's running. Display debug. Oh no, so let's just set the debugs first. Debug. IC all. Okay, and display debug. Okay, and let's do the same thing over here. So my future videos, this is what I'm going to do. Okay, terminal monitor, terminal debug. Okay, and debug all done. Okay, reset IPSA and reset IPSec SA. Okay, reset IPSA. I know I don't have to do this, it's already been done, but it's just normal. Okay, reset IPSec SA. Okay, happiness is. Display IPSA, not there. Display IPSec SA brief. Okay, nothing there. Let's enter a couple of times, get this some space there, white space, so we can find it easy. Right, and let's start. Ping minus A 10.1 2. Sorry, 1.1 going to 10.1 2.1. Okay, brilliant. And that's success at the moment. So what I'll do with you going forward is I want to talk through this, what's happened here, okay, and how it associates with. That's what we'll do, is to figure out what's happening in all of these packets here. Okay, so, and that's what I want to do with you on the other videos. It's crucial that you understand this, because if we had a mistake like before, and unless you've done it many times, it'll be really difficult to troubleshoot. Okay, so you'll see that it's slightly different between the two, and there's a lot of options we can make. All right, and all I want to do is then go through this, explain it to you, the IC phase 1 phase of this, where does it fit into the IC phase 2, and so forth. And just to give you a quick idea, I think we can scroll it up. Okay, so for instance, if you go through it, you'll see that we're going to see at some point that we have some payload message, that's ISMP being used. We said that we're going to use AES CBC 256, there it is being used. Yep, there's a key length of 256. Right, hash algorithm that we said we're going to use is SHA-1, defilement group is 2. You see, so everything we set up was negotiated. But if you get it wrong somewhere along the line, you get some error messages, and that's what I want you to have a look at then. No, so that's what we'll go through in the other videos. Okay, so if nothing else, I hope that you found this quite interesting. If you just do the same commands, you should be able to get basic IPSec up and running. Of course, I don't think you'll necessarily have all the correct choices for your own company, but at least you'll have a basics to start off with, right? And then you can make changes from there. Again, just want to thank you for your time. I hope you found this video somewhat informational. And like I said, watch out for the next video where we'll actually go through these debugs and actually discuss them with you. Okay, thank you very much. Appreciate your time. Bye-bye.